All right, welcome back. We are going to continue our proof lesson. So last time we talked about algebraic proofs and using the statements and reasons to kind of work our way through those examples. Today we are going to move more into some geometric proofs. And in order to do that, we want to look at this valid reasons paper maybe again, okay? And looking through here, I just want to point out some of these. Hopefully you're filling this out as you go and kind of things that you know and some of the things that you may not know or asking me questions about some of them. So a few that I want to point out here. Well, the definitions you should be able to fill out on your own. So like definition of complementary angles are angles that add up to 90. Supplementary angles are angles that add up to 180. Adjacent are they share a vertex and a side, but no interior points. So we've gone over those. The angle addition postulate means that I can add angles together to get a bigger angle, which we've done that before. The segment addition postulate says I can add segments together to get a larger segment. Translation is just a slide, a rotation is a turn, a reflection is a flip. Right here, vertical angles are congruent. That's basically it on that one. Linear pair postulate, that's a definition of a linear pair, meaning that two angles form a straight line, two adjacent angles that form a straight line, they equal 180. I think that might be all we need. Again, you have all of your algebra properties here. This transitive, symmetric, and reflexive properties are going to be used quite a bit. Okay, this transitive property, you should probably put a big star by it. We're going to use that a lot. And what the transitive property is, I'll just go over that one because it's pretty, it is very important. So switch to the document camera. We're going to be on page 41 here. And we're going to title this Geometry Proofs number 1. We're going to do a lot of proofs. Okay, so this is kind of your first entry to geometry proofs. So a big star by the transitive property. And what the transitive property does, and you use it a lot in everyday life, actually, it is a linking property, okay? So an example here would be if A equals B, and then B equals C, and then B equals C, then A also equals C. Okay, you can link things together. So for example, if a basketball, so we'll start here. If a ball is blue, okay, and blue is round, then a ball is round. Okay, it doesn't necessarily have to make sense to you, but it will link things together. Kind of an algebra example here. If 3 equals x and x equals y, so x and y are the same and x was 3, then 3 also equals y as well. So it's linking things together to make sense. Okay, we are going to have 4 proofs, 4 geometry proofs on this section. So I'm just going to take my page here and I'm going to split it up into fourths. So there's 2, and then here's 4. Most geometry proofs will use the transitive property. And oh, there was one more I want to point out. Whoop, one more here. I'm not quite sure where it is. Let's see, maybe it's on the back. If not, we will write it on our notebooks. I don't see it. Okay, let's write it on our notebooks here. At the top again. Didn't quite leave room for it, but that's okay. Okay, so the other one we're going to add, which is used a lot, is a definition. It's a definition of congruence. And we can use this two different ways. What this means is things that are equal are also congruent. Okay, so if you have two things that are equal, you can now say that they are congruent because of definition of congruent. Okay, and we'll see that in some of these proofs today. Oh, I'm already on the... Okay, let's look at our first proof here. So we'll draw a picture. Okay, so I've got a triangle here. ABC. And it says you are given, whoop, you can't see. You are given that the measure of angle A equals the measure of angle B, and the measure of angle B equals the measure of angle C. And you need to prove that angle A is congruent to angle C. Okay, I'm starting off here with a really easy one. Really easy one here, in hopes that we can kind of make sense of how to run a proof. So we're still going to have our statements and reasons. Okay, and you may not know how many you actually need. So our first statement is right here, what they gave us. So it is the measure of angle A equals the measure of angle B, and the measure of angle B equals the measure of angle C, and that was given. Okay, that was provided to us. Now, if you think about this, okay, the next statements or the next reasons we have to think about, okay, and hopefully they're intuitive enough to you that you kind of know. Okay, so A is the same as B, and B is the same as C. So we can say here that angle A, the measure of angle A, equals the measure of angle C. We just kind of talked about that. That was the transitive property. That was linking them together. Okay, but if we look up here, our last statement should be this right here. Okay, I know that the measure of angle A equals the measure of angle B, but I want to know that they are congruent. Well, because they are equal, they are also congruent. Now notice I changed the sign and I got rid of the actual measurement. This is talking about a number, two numbers being equal. This is just talking about two physical angles without the measurements. And I can make that change because of the definition of congruent. So definition of congruent. And I'm done. I know I'm done because my last statement was what they wanted me to prove. Okay. All right, let's look at another one here. You will likely always have a picture with your proof that you need. Okay, so we got C, E, D, A, B. They say that this is 1, this is 3, and this is 2. Okay, so that's the picture that they are providing us. And they say, given the measure of angle 1 equals the measure of angle 3, you need to prove the measure of angle EBA, so EBA is equal to the measure of angle DBC. Okay, so now I'm going to take and write my statements and my reasons. Like so. Okay, the first statement is what they provided me, which was the measure of angle 1 equals the measure of angle 3 that is given. And they've actually already written that on the picture here. If they didn't, I would come up here and I would just mark that. Okay, and I want to know that this angle right here is equal to this angle right here. So in order to do that, okay, this angle here is made up of angle 1 and angle 2. And this angle here is made up of angle 2 and angle 3. So that's what I'm going to say. I'm going to add some angles together. So angle, we'll say angle CBD equals, sorry, the measure of angle equals the measure of angle 1 plus the measure of angle 2. Okay, if I add those two together, I get the bigger one. And the measure of angle EBA equals the measure of angle 2 plus the measure of angle 3. And I can make those statements because of the angle addition postulate or property. Okay, the angle addition property. All right, so the next thing we want to look at, remember, our goal is to say that these two are equal, that this one is equal to this one. And we need to kind of see what's going on here. We notice that both of them have angle 2 in it. Okay, and let's see here. So CBD is 1 and 2. So that's all 1 and 2. And EBA is 2 and 3. So we can do some substitution here and create, here, hold on, let me see here. We can do some substitution because of this right here. I know that angle 1 and angle 3 are the exact same thing. Okay, so I can either change this to angle 3 or I can change this to angle 1. It doesn't really matter. I'll just take this last one here. So the measure of angle EBA equals the measure of angle 2 plus the measure of angle 1. And that was substitution. So we use this fact up here. We use that fact up there. You don't have to draw that arrow, but we use that fact up there to make this statement. Okay. Okay. So now EBA equals 1 and 2. And 1 and 2 equals the measure of CBD. So I can use that transitive property again and say that the measure of angle EBA is equal to the measure of angle DBC, and that is the transitive property. Okay, and I'm done. I know I'm done because I've said what I needed to prove. Okay, you have to use these statements that they give you within the proof. Okay. All right, let's look at that was an angle addition one. Let's look at a segment addition problem. Okay, so they're going to give us this picture here. Let's see what. Okay, so they provide us this picture. And the spacing on these doesn't really matter. That's irrelevant here. And A, B, C, D. So A, B, C, D. And it says you are given that I changed the letters on myself. AB equals SK. And you need to prove AC is equal to AC is equal to BD. All right. So we have statements and reasons. All right, so we're going to start with the given here. So AB equals, oh, I put an SK there, didn't I? This should be CD. So AB equals CD, and that is given. It is not in my picture, so I'm going to put congruent there. Those are equal. They are the same. And I need to prove that AC, that from here to here, is the same as BD, here to here. This is very similar to the last proof that we did. So we're going to start off by adding segments together. I know that AB plus BC equals the whole thing. So AB plus BC equals AC. And you can make more than one statement in a line as long as it has the same reason. So then I'm going to say BC plus CD equals BD. And that is segment addition property. Okay, we're going to do this one just a little bit different. Okay, just a little bit different here. So we could make a substitution like we did on the last problem. We could use this fact and make a substitution here for CD and get AB and make them the same. We could do it the same way, but I want to show you that you can do proofs differently and still get the same answer. So we're going to use the fact that BC in this equation is the same as BC in that equation. So BC equals BC. And I can say that because of reflexive. The reflexive property. That's right under transitive, reflexive, and symmetric property. Okay, so BC is the same as BC. It's itself. Like looking at yourself in the mirror, it's a reflection of it. It is the exact same thing. Okay, and then what I can do with that is I can say, with the fact that this AB and CD equal, I can say that AB I'm using this right here. So BC equals BC. So we'll put BC here. And I'm going to add AB to this side, and I'm going to add CD to that side. Okay? So these two are the same, so I can add them. It's like adding 5 to both sides of the equation. Okay? If they're the same, I can add them. So I took this equation right here, and I added this part to it. Okay, so I combined these two steps into one. That's the addition property of equality. That is adding the same thing to both sides that is equal. Okay, well, you could subtract, AB plus BC, AB plus BC equals AC. So AC equals, and CD plus BC right here equals BD. And what I did is I took those and I substituted it in. So that's the substitution property. Substitution property. Okay, and look, we've said what they wanted us to prove right here. So we're done. Okay, now we can kind of look at some of these angle pairs we've been doing and do a problem with those. So let's look here at this problem. They give us this picture, 1, 2, and 3. They say given angle 1 and angle 3 are vertical angles. Prove angle 1 is congruent to angle 3. Now we know vertical angles are congruent, but that's just because I told you they were. This is actually proving that they are. So in this case, we cannot use the fact, we cannot use the reason that vertical angles are congruent, because that's what we're trying to look at. So statement 1, angle 1 and angle 3 are vertical angles, and that is given. Okay, so 1 and 3 here are vertical angles. Now, we see here that 1 and 2 form this straight line. So angle 1 and angle 2, as well as angle 2 and angle 3. Angle 2 and angle 3, those are linear pairs because they form a straight line. And we know that because of definition of linear pairs. Okay. If you call something something, that's kind of confusing. If you call something an item, you're using the definition of it. Okay. So we also know, since they're a linear pair, we know that angle 1 and angle 2 and angle 3 are supplementary. and this is definition of supplementary angles. Okay. Now, I'm going to kind of change gears just a little bit. Because they're supplementary, we know that they add up to 180. Okay, so we can say the measure of angle 1 plus the measure of angle 2 equals 180. And the measure of angle 2 plus the measure of angle 3 also equals 180. Okay, we can use the same definition because we're kind of just saying the same thing. So definition of supplementary angles. Okay. And then here I have 180 equals this and 180 equals this. So I'm going to use substitution and make them equal. So the measure of angle 1 plus the measure of angle 2 equals the measure of angle 2 plus the measure of angle 3. That is substitution. Substitution. And we know that if I subtract angle 2 from both sides, I get the measure of angle 1 equals the measure of angle 3. Whoop, I canceled 2's. That's the subtraction property of equality. We just subtracted 2 from both sides. Now, this is not what they wanted me to prove. But if the measures are equal, the angles are congruent. So angle 1 is congruent to angle 3. I'm kind of running out of room here. That is definition of congruence. Okay, and now I've said what they've wanted me to prove. IXL has some really, really good practice problems on proofs. So I'll put an IXL out there, and I strongly encourage you to just practice, practice, practice. Proofs are one of the hardest things in geometry. It's why most people don't like geometry, but they can be really easy. Okay, so keep your heads up and keep trying on those proofs. Let me know if you have any questions. As always, I appreciate you watching the lesson. We'll see you next time.